Hey everyone, and welcome to This Explainer. Today, we're tackling one of the absolute biggest bottlenecks of our modern era, EV charging. We're going to look at how some really innovative business models and, honestly, some cutting-edge hardware are totally rewriting the rules of energy distribution. Okay, let's dive into this.
So, the sheer scale of this challenge really boils down to one staggering number: 17 million. That is the expected number of global EV sales in 2024 alone. This isn't just a slow, gradual transition anymore, right? It's an absolute explosion. And with millions of new cars, vans, and buses hitting the streets, we're staring at an enormous, unprecedented demand for infrastructure. Which brings us to the core question of this entire explainer. How on earth do we charge them all without breaking the electrical grid? Because the old way of doing things, it just can't keep up with a 17 million vehicle surge. But human ingenuity is stepping up, and the solutions transforming the industry right now are absolutely fascinating.
Here's the game plan for today. We'll start by breaking down the EV infrastructure bottleneck, then we'll look at charging as a service, explore what it means to unplug from the grid, shift into the battery buffer paradigm, and finally, look at a $130 billion future.
All right, part one, the EV infrastructure bottleneck.
Let's talk about the true cost of infrastructure, because the upfront capital required for the traditional approach is just massive. A standard level 2 charger might set you back, say, $2,000 to $5,000. But a single DC fast charger, you're looking at anywhere from $40,000 to over $100,000. And that doesn't even factor in the extra costs for necessary grid upgrades, trenching, or buying land. For a lot of businesses and cities, those upfront costs create completely crippling payback periods. But it's not even just a money issue. It's literally a physics problem. High-capacity charging hubs need incredibly strong grid connections. And in a lot of places, the grid is already dealing with instability, limited power, and frequent outages. You just can't plug a massive charging depot into a fragile grid and expect it to work without some major disruptions. Let's move to our next section and see how this builds. Section 2, Charging as a Service. Enter Charging as a Service, or CaaS. Basically, this is a business model where specialized providers offer the infrastructure, the software, and the operations entirely on a subscription or pay-per-use basis. The real magic here is that it completely wipes out that crippling upfront capital expenditure we just talked about. It lifts the massive financial and operational burden off the shoulders of municipalities and fleet operators. The contrast is literally night and day. The old CapEx model forces you to eat those high upfront costs, handle your own grid upgrades, and deal with all the maintenance headaches. The new CaaS OpEx model, zero upfront costs, highly predictable subscriptions, and transparent pay-per-use pricing. It makes total sense why commercial fleets are aggressively flocking to this model to save money and just avoid the whole infrastructure nightmare.
In fact, looking ahead to 2026, commercial applications are expected to completely dominate this space, grabbing over 83% of the market. And a lot of that is driven by massive logistics companies. Take Amazon. They're deploying 100,000 electric delivery vans by 2030. They need route optimization and depot charging on a monumental scale. CaaS is exactly what lets them scale up without burying themselves in endless construction projects.
Moving right along, Section 3, Unplugging from the Grid. To put this into a real-world perspective, let's look at the city of Dallas. They recently placed an order for 10 Beam Global EV ARC systems. Now, what's cool is that these are completely off-grid, solar-powered EV charging stations that they're using to support their growing municipal fleet. The way these are deployed shows exactly why this hardware is such a game changer. First off, you literally just drop them into place. No trenching, no construction, no waiting months for electrical permits. Second, they generate and store their own renewable solar energy. And third, they charge EVs entirely independent of the utility grid. That means they offer resilient, immediate charging that works even during a total grid blackout. And this brilliantly illustrates the extreme versatility we get when we scale off-grid charging up. Consider the Udenco DC Mobile Powerhouse, which delivers a massive 400 kilowatts of charging power. Because it's not tied to a vulnerable grid, you can drop it right into a raw industrial construction site. Use it for disaster relief operations, emergency services, or remote infrastructure support. It's basically unlimited power, literally anywhere you need it. Which brings us to Section 4, the battery buffer paradigm. I really want you to let this next insight sink in. Stop treating the grid connection as a fixed input you must satisfy with brute capacity, and start treating it as an energy budget you manage over time. This simple mindset shift completely reframes the entire infrastructure problem. We don't actually need a huge grid connection for massive instant power, as long as we change the mechanics of how that energy is stored and delivered. So, the crucial point is, a battery acts as a buffer. It entirely decouples the instant charging power blasting into the car from the instant draw pulling from the grid. Because the battery handles the massive power peaks needed for fast charging, the grid connection just has to trickle in the slow, steady average energy that the site uses throughout the entire day. Suddenly, sites with really weak grid connections that were totally useless before are perfectly viable. To see what this looks like in practice, that Oud & Co mobile powerhouse uses two 175 kilowatt-hour liquid-cooled battery racks. That is a massive total capacity of 350 kilowatt-hours. It's heavily protected, too, IP67 rated with a full aerosol fire suppression system. That durable, massive storage is the exact buffer we're talking about. It safely sips energy from a weak grid and blasts it into vehicles at lightning speed the second they pull up. Finally, Section 5, a $130 billion future. The financial numbers backing all this up are truly exponential. The global charging as a service market was valued at about $16.89 billion in 2025. By 2026, it hits $21.87 billion. But check out this growth. An explosive 24.98% compound annual growth rate is expected to push this market to over $130 billion by 2034. That exponential leap is driven entirely by the critical necessity of these new deployment models. And geographically, the Asia-Pacific region is absolutely dominating right now, holding over 75% of the market share. A huge driver of that is China's massive EV adoption and their staggering network of 1.8 million public charging points. Europe is sitting at about 18%, while North America is just over 4%, which just goes to show how much untapped, rapid expansion is coming for Western markets in the near future. So when we put the whole puzzle together, the main takeaway is clear. EV charging isn't just some brute force capacity problem anymore, where we try to install bigger and bigger wires. Now, what's really interesting about this shift is that it's evolved into a highly dynamic service and an incredibly smart energy management puzzle. It's a perfect example of human ingenuity outsmarting physical grid limitations using clever business models and buffer tech. I'll leave you with this final thought to chew on. How will this off-grid, service-based paradigm shift alter your city's infrastructure and your own business over the next few years? The charging revolution is literally untethering itself from the old grid, and the possibilities are wide open. Thank you so much for hanging out and exploring this explainer with me today. Keep learning, keep questioning, and I'll catch you next time.